So let's start. And last week I was continuing and testing the SeaStor Rise RocksDB, and it turns out that I can have the latency was caused by, well, I can reproduce the performance regression using the built-in test benchmark provided by SeaStor. And per my test this morning, the sequential write performance is actually kind of upon par with the POSIX backend. I need to repeat the test more today, and I also started working on porting the SeaStor to SeaStor, and I think it's a long way to go. Aside from it, I was reviewing Redux Aerator PR. I think we can get it merged very soon. And that's about me. Actually,
Hi, Kefu. So I have make the alien submit 2 works. It's because the SeaStor check the SMP counter. If it is only bigger than 1, they created the SMP message queue. So for us, we just use SMP only 1 car. So I just template set it. It is equal or bigger than 1. We always created the message queue. So the alien submit 2 works, and I add in the when the OSD called the alien BlueStar, I create our own register our own uncommit. So when the BlueStar finish thread running, on that commit function, I set the promise set value. And then in the SeaStor side, we call the promise get value. So when that finish thread set value, then the alien store will get the value, then return to the OSD. So the then function will be called, will be continued. But peering in the PG, the peering state, it registers its own uncommit. So there are 2 uncommit registered. One is the PG peering registers his own uncommit. Another is my own uncommit for the guaranteed BlueStar finished. And so there is a little confliction, because on my own register uncommit, the context will keep alive, will not be deleted in the finish thread. I have to keep it alive until it get promise get future back.
You shouldn't have 2 contexts, right? The one you're queuing over to AlienStore and then that comes back should do the work of cleaning up all of the commits that were queued, not just yours. Or all of the, I'm sorry, not commits, contexts.
Pardon?
So even if 10 commits are, or if 10 contexts are registered on the transaction,
yeah,
BlueStor should only see, hang on, BlueStor should only see 1, yours. Your context should take care of running the other 10. Does that make sense?
But I think your contact will still works, right?
I don't know exactly how you wired it up, but it sounds like that's the problem.
If you register on commit will just push back, right? So every register on commit will push back in the queue.
Right. So when it goes through the interface barrier, you need to treat that as a set of things that have to be called when the commit is complete. And your callback needs to do that. You have to wrap all of them. In other words, you can't just run them blindly because they expect to be run in that context. sorry, I shouldn't have used that word. They expect to be run in the same thread that the OSD is in because they're accessing the same memory, right? So you have to take care of hiding that part. The BlueStore will only ever see your wrapper. Your wrapper has to take care of running the things that were queued on the transaction. Registered, sorry.
So I'm not really understand. So can we just because it just push back into the queue, so it will pop out one by one and execute one by one on the for the commit.
Right. In other words, BlueStore itself, like the other side, the alien part that's running normal BlueStore and normal threads, should never
Yes.
ever see a context from the OSD. Ever. It should only see wrapped contexts. You can either wrap them individually and use alien submit inside of each one, or you can just leave one context on the transaction when you send it over and make that one run all of them. Either way, it doesn't matter.
I think, in other words, you need to wrap around the existing context with a wrapper, and so let the wrapper to manage the life cycle of the wrapped context.
I mean, there's that too, but it also needs to run it on it needs to use alien submit or whatever to make sure it gets run back over on the Crimson thread, SeaStor thread, sorry.
So why we need wrapper these two contact? So we can just run one by one, right?
Yeah, so you can wrap them individually if you want, but the point is that these contexts get run in BlueStore in the finisher thread, which is not the SeaStor thread.
Yeah, I just called the alien submitted to SeaStor thread. In the
for each one?
For each one, yes.
Then what's the problem?
The problem is that because my context, but in the finisher thread, they will delete the context when they after executed the function, they will delete it. But for my mechanism, I have to keep the context, the object alive until return to the alien store from the BlueStar to the alien, to the SeaStor. I need there is the promise get future wait there.
Right. So what BlueStor should do is it should be running a context that you constructed that that uses alien submit to send it back to the other one, and then when it deletes that context, it doesn't matter because the memory we're talking about has already been submitted back, right?
Yeah, but I have let the finisher thread to identify. Okay, so for my own context, I have a member variable that is the promise, and in the finisher thread, the promise will be set value, and then in the before I call the POSIX thread submitted to, I have to wait there until the promise available. So I couldn't delete the context in the finisher thread, but for the PG peering context, it has to be deleted in the finisher thread. So I have to identify which context can be deleted in the finisher thread.
No, you need to wrap it so that I'll have to look at your code, but the answer is that what BlueStore is seeing should be deletable because it ran it, and that's what contexts are, right? So the action of running that context needs to trigger behavior on the SeaStor side that runs the real callback. BlueStore should never have seen the real callback.
Yeah, see, I do it, and so I will send an email to describe the problem I meet.
Well, I think I remember where this was in your branch. So if you could, in your email, just also include the branch so we can just look at the code.
Okay. So like that's my side. So I'm just debugging on the peering state, and then make sure it get active wait PG wait for active works, and then it should be worked for Rados bench.
Thanks, Trimi. I just want to note that the native version of BlueStore could be competing with your alienized ROX BlueStore. If the performance is better, the alienized BlueStore will buy us a lot of time before we have the native version. If it turns out the native version cannot, the performance of the native version cannot beat or at least on par with that of alienized, it will be deprecated. That's my
So
understanding.
I think if I pin the thread pool to one CPU core, it seems all the created thread is binding on the certain CPU core. So maybe we need to create a more create the thread pool on more CPU cores, not only for one CPU core.
Well, hang on a sec. I think we're getting ahead of ourselves. It sounds like we're pretty close on the alienized BlueStore, so it's probably worth going ahead and finishing it and seeing where we are performance-wise. So I think we're on a good path for now.
Okay.
Yes, that's also my understanding. But Trim, I didn't follow you. You're talking about the SeaStor reactor or the POSIX thread
It's
managed by the
BlueStore's
thread
thread
pool.
pools. BlueStore's got like a thread pool of like 2 standalone threads and a finisher thread.
Yeah, currently for the POSIX thread pool, I only pin to one CPU core and just create one thread, POSIX thread. So the BlueStore will create many sub POSIX thread, and it seems I just found the finished thread also running in the CPU core. I pinned the thread, so it seems all the sub thread, all of them scheduled on the same CPU core. So maybe we need to create a more thread pool, thread on multi cores.
That could be true. We'll have to see.
Redek.
Hello. Last week, well, let's start from the aerator stuff. It turned the perf check bot has unveiled that we have a failed to build from source issue, but only on a newer version of GCC, on GCC 9. It turned out that aerator was making use of very likely a GCC bug. Thanks, Kiefer, for idea for fixing it up. I pushed the fixes to the branch. Also, in things related to performance testing, 2 PRs. One actually switches the build type to release for the perf check Jenkins job. That's the one-liner merged yesterday. I'm not sure whether we need to switch the default type of build for the CMake.sh. Actually, the CMake build type option appended here gets priority over the default debug we have in the CMake. Second issue is related to the fact that we are actually that perf is actually doing sequential. You hear me?
Yeah, you may want to disable your camera.
Sorry, I've got a network glitch.
No, we don't hear you
Is that
anymore.
better? Can you hear me?
Yeah, the microphone's working
yeah.
fine. There was just a bandwidth glitch. You may want to disable your camera. It will probably make it better.
Okay. I switched the perf test Jenkins job to do random reads instead of sequential reads right now. The issue is related to how Rados bench internally operates. Basically, the number of reads issued in sequential configuration is very limited. On my machine, the entire run lasts in half second. I pushed the fix for it. The last thing is that I'm working on watch notify mechanism for Crimson, and this intersects a bit with Sam's work on object context. I need to put ephemeral state of notify and watch to object context as well. That's me.
Ronan, how's it going?
Hi, everybody. I have a working admin socket that able to handle config set, which was the original target. I wanted to be able to change the debug setting during operation of the Crimson OSD. Now I have it working over the Unix domain socket. It still needs cleanup, and then I push it for review. But most of what I'm planning now is mostly work on understanding performance testing and doing performance tests, probably on one of the labs, not on my laptop. So this will be the main focus of what I'll be doing. Just one note, I'm like everybody here in Israel we are on vacation until the 22nd, more or less. Today too is a holiday, so we are more or less absent until the 22nd. So I don't expect much to be done until more or less the end of the month. So that's from my side. I hope to be able to push that PR in a few, probably before the end of the month.
Enjoy your vacation.
Thank you.
Sam.
Yep, I'm working on refactoring the write pathway a little bit. Basically, I'm pulling. There are several blocking bits, or just one, I guess, getting the object context, that I'm pulling up into the write operation itself, because I want them to be blockers, so they'll be registered in the sort of dumpable format that tells you why ops are blocked. And at the same time, adding the object context ref. And right now, I'm working on. I extracted the read-write state lock state machine from object context in classic OSD because it's a giant ball of special logic that I didn't really want to duplicate. But I left all of the stuff about queuing, op, requests, refs, and such over in primary log PG or whatever, so that we don't have to deal with any of that crap. Instead, futures will just try to obtain a lock of the right kind on the object context, and they'll get a future back, and they'll suspend until they get to keep going. So it'll be a little bit more ergonomic than classic OSD. Radek, I expect to have at least a reasonably functional version of this bit of the patch series by like Monday. Does that work? Or if not, I can just give you what I have so far, and you can have a look at it and go, eh. I'll do that, actually. I'll send you an email tomorrow with what I've got.
Cool.
I may wind up reworking parts of it, though.
Cool.
I'm going to try to give like a small Crimson talk at Ceph Day in San Diego in November. That's it. Just, what Crimson is and what our current state is.
Are you going to do some performance tests, get some numbers?
I'm not going to produce anything new for this. It's just a set day, so I figured I'd just give a brief overview of the project and like what its purpose is and where we are. It's mostly users, so it's not so much like developers. This is more, here's something you may be interested in that's probably a year to 2 years down the pipe.
I see.
Although I'll happily steal any numbers other people have already produced.
Okay. I'm just wondering if you wanted to do some performance tests to show the difference between the classical OSD and the Crimson OSD to.
I think that you guys have already done a lot of that testing, and I am hesitant to invest very much time in that before we have a disk back, like before we have something that writes to a disk.
Okay, if you want, I can do the test next week, because I think I need to do some of them.
We have automation for this now, right? Can't I just steal the stuff out of the automated test runner?
Yes, we have the CI integration of the CBT.
Yeah. I don't think this is a thing to spend time on, is all I'm saying. Don't go out of your way.
Guys, but this make the perf check bot won't help us because it does comparison. It compares between two versions of Crimson. We are lacking comparison with classical OSD. It wouldn't be a big deal to add such thing, to add such automation, and I believe we need to do that because of the testing we need to do for management.
If we want to do it anyway, then by all means, that seems solid.
Yep.
Okay, Yixin, welcome back.
Thank you. Is there any issues from the messenger these 2 weeks? Because before I goes to vacation, just a lot of code merged.
Not so far.
No, okay, that's good. So currently I'm working on testing. There are some frames I didn't add it to the test, like act frame or keep alive frame. If they failed, I just adding the failure of act frame and the keep alive act frame to our current unit tests. And there are some other missing features in the messenger I'm working on. I will list them maybe in the card. For example, I saw the goal, Kefu, your document about the goal and the tasks of the Crimson Messenger. There's a config. Messenger currently is using the hard-coded configuration. It didn't use our current config implementations for the SeaStor framework. So it is one missing feature, and another maybe it is like connection timeout. Like if the socket is blocked, like we cannot send anything out or read anything from the socket. It just stops there, and there is a timeout mechanism in async messenger. So I think I also need to add it to Crimson to detect the network issue during ready state. And if it time out, it needs to reconnect again, like there's and loop back, like so on. There's some like
Sorry,
3 or 5.
What do you mean by the loop back? Is this a specific connection type only for performance tests? Which was mentioned by Casey. Okay.
Performance loopback is not implemented yet. The loopback connection.
Oh, I see.
Yeah, actually, the EC backend in Classic OSD uses it. It sends messages to itself in some
Do
cases.
we need
Okay,
loopback connection? Where do we need the loopback connection? If I implemented this feature, who will use it?
Well, it depends on how we choose to implement erasure coding, but as a shortcut and because it was there and because I was lazy, when I was implementing the original EC backend, you'll notice the primary actually sends messages to itself
Mm-hmm.
so that it doesn't really have to reason about the difference between primaries and replicas, and because it actually turns out to be a fairly convenient way to separate the work queuing.
Mm-hmm.
Arguably, it's
So in
like
our current implementation, do we still need this?
I'm guessing probably not, to be honest. Like it requires some kind of weird behavior from the messenger. Like for performance purposes, you really need to not encode stuff, right? So the messenger needs to know about the distinction at several layers, which seems annoying.
Yeah.
So if you want to argue that this is irritating to implement and that we don't have any users, I would be with you on putting it off.
Okay, so I will not implement it until it is needed. So I'm just curious.
Unless anyone else can remember a case where we use it.
Yeah, so I think so. I will not implement unless someone needs it.
I think that's a fair point.
Yeah.
We can make it a stretch goal unless it's proven to be necessary.
It's more at some point we will run into something and it will either be more convenient to do it this way or it won't be.
Mm-hmm.
And at that point, we'll implement it.
Okay. So that's what I'm going to do next.
Okay.
So,
So before concluding this stand-up, I just want to remind us that I published the two plans. One is the Crimson plan, another is SeaStor plan. The former includes the timeline of the different action items. So probably we need to reprioritize our tasks accordingly. Some of them, I have a very short discussion with Josh, which encouraged me to prioritize some of them. So to decide which one of them can be completed before Octopus. So if you look at I'm posting the URL in the chat window. If you look at the document, you will find that some of them have Octopus noted aside from the main month, the number of main month. Another thing that we need to click on.
Can I add some items related to Messenger in this goal?
Please feel free to it.
Okay.
I will update the GitHub copy when we finalize it.
Suggestion: it might be easier just to have people commit to the GitHub one. I didn't create it to make it hard to update. I don't think it should require any reviews or anything. I think you should just be able to modify it and commit immediately. That way there's only one version of the document, not two. Just a suggestion.
So please just edit the GitHub version. I'll post the GitHub version in the commit diff notes. I believe that's
I only created the GitHub repo because it was difficult to share Google Docs outside of Red Hat. So this is like Google Docs, but easy to share outside of Red Hat. And I think we should treat it like that.
Yeah. So this is the one without the timeline, because the timeline is subject to change and still under discussion. But if you wanted to add in more fine-grained the object targets, please feel free to edit on the GitHub and push it. I believe every one of us should have the privilege to push it, right?
Anyone who has commit access to the repo should, I think.
Cool. Another thing is the SeaStor plan. It's far from plan actually. So it's more like a list of reference. So we could take a look at to get some some inspiration regarding to our design. One of them is a SeaStor design in our repo.
Is there a native BlueStor plan? A plan of native BlueStor? Will native BlueStor re-implement the BlueStor in SeaStor world?
I think it will be, to my understanding, it will be more like a port of existing BlueStor and RocksDB.
How much code do you plan on replicating?
Yeah.
Currently, on the RocksDB side, it's like 1,000 to 2,000 line of code. And
is that just a plugin, or do you have to change the text of RocksDB itself?
It's just the extension.
That's totally fine. Okay, yeah, that's
I'm not
good.
touching
okay.
I'm not touching.
What about BlueStor?
Okay, that will be, I would say that will be intrusive change. So my plan is to replicate the first step. I think I can think of is to clean up the existing code tree of BlueFS and BlueStor to make it more readable. And the second step, that's what I'm doing now. The second step, I think, is subject to change, depending on discussion. Next step is to replicate them, like what we did on memory store.
I would argue that I would argue that that's an extremely bad approach. I think anytime you copy code like that, especially something as complicated as BlueStor, we're never going to be able to keep up with the bugs. It means every bug that gets fixed in BlueStor has to be copied over and fixed on the other side too. The only way my contention is that the only way this project works is if you extract the parts that care about the difference between POSIX and SeaStor into a plugin infrastructure, not unlike RocksDB.
Okay. Yes,
I genuinely think it is 100% unsustainable to have two copies of BlueStor.
Okay.
Even if Sam, even if later we remain with only the new one.
We're gonna have to live with this for years, man. I mean, 8 of them. There's no way. No, they're going to be existing. Like the day we switch officially from Classic to Crimson, there will be 5-year support customers, right?
Yes.
So okay. I stand by my statement. Like that will be years from now. That 5-year cutover point. That point at which we say Crimson is now the OSD is 2 years off, right? And from that point, we have to support Classic for 5 years.
Yes, very true.
So no, I don't think we can support 2 versions of BlueStor. I think it's worth doing this correctly and extracting a plugin infrastructure. And actually, when you guys are doing general things where you're porting over code from Classic, you should think in these terms. Try not to copy anything that's genuinely complicated. Like do the work to refactor it. I'm willing to be convinced otherwise, but that's my instinct right now.
Did we ever try to?
So yes, but yes.
Did we try to take a piece of code and futurize it, not in SeaStor meaning, but just as in regular non-SeaStor compilation, using standard futures and just to mimic the way SeaStor
it's surprisingly difficult. It's surprisingly difficult, and the reason is because the way SeaStor futures work, they know they have thread local state that forms the rest of the picture. Like the futures that are provided by C++ are much weaker than the SeaStor ones because they don't make assumptions about a bunch of thread local state that makes up the reactor. They have the same word attached to them, but they accomplish different things. which is not to say that we couldn't go that approach. I actually did think about that a while back, which is why I built like a SeaStor agnostic futures thing. So we could create like a work-alike future, or create like a version of like the OSD thread pool that replicates some of this behavior. That's an approach too. I'm open to that also. But for BlueStor, I suspect that it won't be as bad. I think, at least it's not obvious to me why we couldn't do the same kind of refactor to BlueStor that RocksDB already has. That makes it possible to use the thread switching behavior in SeaStor. I'm sorry, the stack switching behavior in SeaStor to accomplish the same goal. Like if we stub that. Exactly. So in RocksDB, right, they have, you provide an environment interface implementation that tells it how to do things like lock mutexes and create threads and stuff, right?
Yes.
So RocksDB, or BlueStor is similar to that. It has some threads, it has some mutexes, and it has a few other things. But if we can identify all of those things and create a plugin infrastructure for it, then we can make BlueStor itself agnostic about which environment it's running in, and then Classic and Crimson would simply provide their own implementation. Same thing you're doing for RocksDB.
Okay.
I need to think about it. Will this approach hurt the performance?
I don't care about the performance because I'm 100% sure that we cannot support 2 copies of BlueStor.
No, but the problem with the performance, Sam, the problem is that if we do impact performance of regular OSD, changes.
Ronan, BlueStor is never going to be the performant option for Crimson, ever.
No, I understand, but what I'm saying is that changes to it must not hurt performance of regular standard OSD.
It's unlikely that they will because of how inefficient BlueStor already is. But I agree, that is a design constraint. But remember, what we're talking about here is at worst, like an extra indirection for certain POSIX calls that were already going to be sys calls. And I'm having trouble seeing that as a major performance problem.
Yeah, if this is all that's needed, of course, but I'm not sure we'll be able to hide the whole model change that.
Well, keep in mind, BlueStor's performance is heavily dependent on RocksDB's performance, and RocksDB already does this.
Okay.
I mean, are you guys really arguing that it's a good idea to maintain 2 copies of BlueStor?
No. I would rather not. Actually, I've been struggling myself, thinking about two copies of BlueStor will be a pain because I was keeping an eyes on the recent development of BlueStor, which has been actively development also. So it will be a nightmare if we want to keep trying to catch a flying arrow like BlueStor.
Yeah, we'll never be able to do it. Plus, there are some fringe benefits to this too. It's a lot easier to test for threading bugs if all the threading libraries are factored out. Like you can create testing mocks that make it a lot easier to surface bugs like that. So there will be fringe benefits for people that aren't us.
Okay. I rethink the approach, how to factor out the async calls in BlueStor and BlueFS.
I mean, I do think we shouldn't try to make it not synchronous. That seems really hard. We should do the RocksDB thing and just hide it with SeaStor threads.
That's what I meant. If we are not going by the way of making it async.
Well, it will still be async in the sense that it will run on a single core and it won't block. It's just that the code won't be written in an async way. And as a medium path, that strikes me as a reasonable trade-off.
Yeah.
BlueStor is a
Well,
lot of
if
code.
if you look at the
to...
RocksDB ports, all the async call will be wrapped like do some async dot get. So that thread will be swap out and swap in by SeaStor. So that's transparent.
Yeah, it's a little more expensive. Well, it's more expensive than a raw future because you do have to do a stack walk, but it's not like catastrophic. It's certainly still way cheaper than a context switch.
Yes, that's
a question.
That's how I was looking at. The latency is much higher than a plain system call. The plain system call take like two or three microseconds. When it comes to a write driven by reactor, it's like 10,000 of microseconds. I'm still looking at it. Why the latency is that high?
Well,
You can reproduce this test using the IO stream perf offered by SeaStor.
Well, it's not even an IO
IO
thing.
depth is the one.
It's just a task switching thing. Mechanically, you don't have to make a call into the kernel. You don't have to clear registers or any of that. It's just switching the current stack.
Yeah, I'm
Ronan, does that make
latency?
Right. I'm saying the latency is that. Yeah. Go ahead.
I have a general question. We are a few times, even now, we are talking about having threads that are wrapped. Are we open to using a dual core infrastructure, which means we are still maintaining SeaStor as one for OSD for time at least, as using one core, but we are allocating a pair of cores. The other core will be used for all non-SeaStor.
That's what Chunmei is doing right now. That's what Chunmei's Alien Store is.
Yeah.
But
so that's
Alien
almost prototyped.
But what I understood from the earlier talk was that we are still using one core for this. More threads, but one core.
One core for Crimson, and then right now, by whatever fluke, it simply happens to be pinning them to the same core, but there's no reason it has to.
Okay. So
yeah, that's not fundamental. And it was called out as a performance thing we'll probably have to fix.
Okay, because that's, if you remember, I asked the questions in emails a few weeks ago about it. I was trying to understand why we have so many context switches if we are guaranteeing that SeaStor is never interrupted by the alien threads. We guarantee we're using affinity or whatever that only.
Okay, so in that case, it's not a context.
So yeah.
In that case, it's not a context switch. It's a inter-core communication, right? Yeah. It's still vastly more expensive than making a call within SeaStor itself.
Only because cache coherency issues, or why is that?
Yes, and it may have gone to sleep, right? The other thread might not be scheduled at all. And also, BlueStor doesn't have just one thread. It's got like 5 of them.
Okay.
So if they're all pinned to the same core, there will be actual context switches. If they're not, which they shouldn't be because they should be because none of them are going to consume a whole core. Let me put it that way. So for them all to be pinned to their own cores, such that they never go to sleep, we'll be wasting like 6 times the CPU that we need to. In other words, BlueStor actually uses the OS as a scheduler, if that helps.
Okay.
What we're talking about with native SeaStor here, or natifying BlueStor, is SeaStor has this trick where you can run regular synchronous code in the SeaStor reactor, and when you call a blocking operation on a future, SeaStor will transparently swap out the stack and move on with its life. It's not a real
Basically,
thread. It's a green thread. Called the SeaStor thread. Hang on. It's called the SeaStor thread class, but it is not a thread. Okay, go ahead, Ronan. Sorry, Radek.
It's just a green thread implementation of threading made entire register level. It's bases on on send jump, long jump, all that stuff that actually records and restores your stack. The question here might be related about whether in SeaStor, our stack, the content we need to restore, we need to save, is larger than in case of running BlueStor inside classical OSD. That might be one issue, but I'm not sure whether the performance is a problem here.
And this is why we're still pursuing Chunmei's approach as well, because it's almost done, for one thing. So we will be able to test them. As far as the impact of performance on BlueStor and classic OSD, I'm not tremendously concerned about it, because in the worst case, we're talking about turning what would have been a static call to a library function into an indirect call on, and that has a cost, but it's not a big one. Given that most of these things actually do cause system calls, I think it's a worthwhile engineering investment to see if it actually does cause problems. If it does, then yeah, we got to get clever. But
Yes, I think we can assume that won't be a problem.
Yeah, at least it's sufficiently unlikely that it's worth the investment, I think. Does that assuage your concerns a little bit?
Yeah.
Maybe one more generic question. Do we really need, is the SeaStorized BlueStor absolutely necessary?
Now that's another genuinely interesting question. So we don't currently know that we need BlueStor at all.
But I think we do need, right? Because the disk layout of a SeaStor should never work with HDD if we are going to utilize the read-and write.
I'm not sold. I've been talking to so let me put it this way. I think it is the case that we want to be sure that our implementation will work well with the thing that's like SMR but for NVMe, Zone NVMe. Those things are append only anyway.
Oh.
Because of the way the flash works, right? The only media that exists today that is truly random access is this like NVRAM stuff. And actually, it's not clear to me that NVRAM won't be used with hard disks. For one thing, it's an incredibly cheap memory technology. If you're not using it for persistence, you can get a lot of it for the same price compared to what you get with DRAM. So if the assumption is that you have some kind of fast, persistent or non-persistent fronting cache with some kind of sequential optimized, not append only, but append optimized slower tier, then it's not totally clear to me that zone-based NVMe is different from hard disk. Faster, yeah, but not necessarily different. The most obvious difference is in random read access. So that may matter. But it's not like BlueStor is really that good at random read access anyway on hard disks. There's really very little you can do about that without some kind of really capacious cache.
So what we are back to is that it is a viable option to not need to maintain two versions of BlueStor in the future. To remain only with our SeaStor.
Well, conceivably.
And if this is okay, and what I'm saying is that if this is a viable option, maybe it's still a viable option for the time being, do maintaining two versions of BlueStor, which is much simpler than just changing.
Yeah, I'll go one simpler. I would argue that if we're going for a short-term solution, we should use Chunmei's. It's almost done. It
Okay.
requires minimal changes to BlueStore. It doesn't require two copies. It just works, right?
And invest
so
all our
Kefo
work,
is-
invest.
Kefo is-
Few of us.
Sorry. So Kefo is going to porting RocksDB SeaStar to BlueStar, right? So what's the difference for the SeaStar BlueStar?
Yours is almost done, and Kefu's is still in the design phase. That's the difference.
Yes. Yes. My goal is to try to, because it's would be very difficult to maintain two application stack. One is the classical OSD, another is based on SeaStar SeaStar. So that will be pain.
Let me suggest a decision tree. So I think the way this works is, for now, we work on finishing Chunmei's one. Kefu, you continue doing some design work on that. It may not be hard, right? But the real question is, we're going to start developing an actual design for SeaStor by like December,
Yes.
right?
Yeah.
So pretty early in that process, we will have started prototyping things, and we will know whether this design, because we're not going to make choices that hurt the high performance case to support hard disks. So we should know pretty early on if we can actually make everything happy, right? We may encounter something early that's like, oh, we definitely don't want to do this on a hard disk. So yeah, we need BlueStore. So I think that's the point at which we start figuring out how we want to make BlueStore work really happily in the future. And until then, we, use the simple separate thread thing.
I'm all for this. I think this is a good way to invest our efforts.
Particularly since SeaStor is the genuinely important thing, right?
Yeah, exactly.
And by the way, Chunmei, I think your work is very important because it's the alienized BlueStore is being well tested, and its performance can be granted almost. So my work is just to eliminate the effort in long term for maintaining two stack. But in practical, we need to do, because we will maintain the classical OSD on one hand and the Crimson OSD for like Sam mentioned, it would be last like more than 5 years. So I'm imagining the thing after the 5 years, something like that. And also it will be paying to use this to stack in the one application. That would be very difficult to debug because two of them have different expectation. For example, one of them are using the classical OSD logging. Another one you will be using the SeaStar logging. So as such,
after you porting RocksDB SeaStar RISE the RocksDB to BlueStar, the BlueStar running in SeaStar's RISE or in the Postgres RISE?
SeaStar's RISE.
So
or driven by Reactor.
The point is, it's possible we never get around to actually creating that version, which is why we need yours. Does that make sense?
Yeah.
Okay.
My project could fail, and yours
are
very likely.
Or it could be that SeaStor is good enough for hard disks, right? BlueStore isn't a magic bullet. It's not unbelievably good on hard disks. It's not really that hard to imagine that we kind of back into a design that actually works fine on both.
That would be holy grail.
I don't know. Like I said, I have some reasons to think it's not implausible, but again, random read latency is very different. So we'll see.
We are planning, and we will be working on SeaStor plans during the San Francisco meeting, right?
Yep.
But
I think that's
I encourage you
identifying the key questions and decisions will be one of the outcomes of that meeting.
Yeah.
Kifo, what did you say?
So I encourage you to collect some background and facts before we go to there. For example, I have no idea about the zoomed flash and
okay.
Something like
I'll
that, Panda only. So that would be very helpful. Sam, could you put some reference?
I'll I'll write up a quick state of the industry summary.
Yes.
And can you
some
link
links
it to
that would be
the
helpful.
I'm going to add it directly to the
can you
SeaStor design document.
exactly.
Exactly.
The SeaStor
that's-
plans that
That to me is a key design question. Like, what hardware do we want to support? What things does that like force us to do in our design, right?
And for example, one of the issues that already popped to my mind is the how prevalent will be systems with a PMEM cache.
Yep, that's the other thing.
On the way to the disks, because then there are some things that we may be able to do that would benefit performance.
Direct remote PCI Express memory operations from the primary to the replica. That's what I want.
Okay,
no, seriously.
Yeah.
You could, like, if the primary and the replica have the replica can say, I have reserved a gigabyte of space for you starting at this offset on this PCI Express device. Please dump any replicated operation you want to that queue in order. And don't wait for me to acknowledge it, right? Then all you have to do on startup or whenever the peering state changes over is make sure you caught yourself up on all these logs you didn't notice. It completely eliminates all of the queuing latency on the replica side. There are a lot of tricks you can do with persistent memory and the new NVMe stuff. I'm excited.
Okay, RDMA directly to the other side, to the replica, doing RDMA directly to the memory of the persistent memory of the...
It's not just that. The replica and the primary need a protocol set up so that they can communicate about how much buffer is left and that kind of stuff. And there's recovery stuff that needs to be worried about. And when you flip over the peering state, you have to bound how much work has to be done, or else you could create some idiotic amount of peering latency. But, I mean, this is all doable.
Yeah.
Probably further out, but doable.
But it will change the fundamental design of the protocol and the underlying.
It will change the protocol.
Object store.
It will change the protocol and the object store, but shockingly, it doesn't really change RAIDs at all. No. Replicas are barely involved in writes. Their only real purpose in life is to remember the log.
What I mean is that we need to, if we want to go that way, we need to. It's a no. So
for the record, this isn't an early design goal. But it's things like this. Like there are other capabilities of NVMe that we do care about. Like zone NVMe devices are going to be a lot cheaper because there's no flash layer, there's no FTL layer, and for industry reasons, we probably have to target that immediately. So that kind of thing does create hard requirements. Huh?
Yeah, I think it's.
What you said about immediately, why?
Not immediately.
Why is
but
it?
Because by the time Crimson comes out, they're going to be really common.
Okay.
Because they're a lot cheaper. Like they are potentially a lot cheaper and a lot faster. Essentially, it eliminates the entire flash translation layer that current random write SSDs have to maintain. All they have to maintain is a memory of how many writes each zone has seen and the current write pointer in each zone. That's all the SSD is responsible for. SeaStor would be responsible for everything else. Where leveling, remembering where it put stuff, which zones are open, which ones are closed, how full they are, all that stuff.
Oh, that's a lot of.
It's a lot of extra
details
stuff.
Yep. And not enough CPU power for that. We don't plan to invest.
The thing is, we're spending a lot of that CPU anyway. Keep in mind, we already maintain offsets for stuff, right? BlueStar already has offsets for its data blocks. The only problem with a current SSD is that there's a second offset in the SSD, right? We pay it again for some reason. And for performance reasons on even a current SSD, you really want to write sequentially anyway, because if you write randomly, you generate a lot of garbage collection traffic, which causes big spikes in tail latency on writes. So in exchange for eliminating all of that, you now have to also make sure you wear level the blocks. But given the trade-off, it's a lot cheaper, like way better.
For the general purpose NVMe, not the append only one, I think if we were right at the the right operation is the block line. We don't need to worry about the width or garbage collection. If the life cycle of the pages align with other pages in the blocks, we're safe.
Yeah, that's true. But
if we take that into consideration of the disk layout,
I think what we do is we would write, well, probably this discussion right here. This is the outcome we want of the initial design discussions and experiments. We should be able to get samples of zone SSDs from Western Digital, I think. Yeah. Hopefully, maybe not very long from now.
Random.
Yeah. So we'll start that. We'll have to prototype, right? But my guess is that whatever workload we would have generated for a zone SSD will be optimal for a regular SSD also. The only difference is we won't have to bother with moving with wear leveling. That's my guess.
I don't think we need to worry about wear leveling on a classic NVMe SSD.
No, you don't. You don't do that. You don't do it at all on a classic one. But the choice
FTL.
of where you. I'm sorry.
Or FTL.
No, the FTL has to do it. The FTL
so
does
we don't
have
need
to do
worry
it.
about it.
We don't, but the FTL does. What I'm saying is the layout we choose on the disk will be pretty much the same. It's just that we won't actually do the wear leveling. We'll just let the disk do it. But we'll want to target the same write patterns.
So I just think we need to target, if we can take advantage of a random write, that will be fundamentally change our design. If we target the append only, then both of them can be benefit, but we lose the advantage of random write.
So the parable of that is that actually random writes to regular SSDs are incredibly dangerous in terms of performance variability, because they generate write amplification. So RocksDB on a conventional SSD that Western Digital had a booth, Budolib was doing some experiments. He's a PhD student who's been working with Sage, or has a PhD, whatever. He was saying that even if you set up RocksDB to use RocksDB just does sequential writes, right? That's all it does.
Yeah.
You still get a write amplification of 4x. And the reason for that is that when RocksDB is writing, it generally sends 4 concurrent streams, which ideally should hit 4 concurrent erasure blocks. But in practice, because of the way the FTLs usually work, they usually hit the same erasure block, because for physics reasons, they don't like leaving erasure blocks open for writes for very long. So as a result of that, even though ideally that workload shouldn't have generated any write amplification at all, you get 4 times as much as you're supposed to get. And 4 times as much as you're supposed to get means a bunch of things. One, you're going to have to copy that data 4 more times, which means the media only lasts about a quarter as long, and a bunch of I/O gets eaten up in the background, moving the data around when you do erasures to free up space. So while it is possible to do random I/Os, it is in many cases preferable to choose a layout that avoids it, even though it's possible.
So we don't get the free I/O free.
We're paying for it. We just don't
do it wrong, right? Do it the wrong way.
We're paying for it anyway. We just don't have any control over it. So that's why I'm saying it's not totally clear to me that those will be different write patterns. But we're going to have to do experiments about this. We'll need more understanding before we nail down a particular approach.
Yeah, I need to some more quotations from different sources to convince me that.
Yeah. And that may have been some particular behavior of just that Western Digital FTL, right? But this is similar to what I've heard from other people, and that's why the zone NVMEs are a thing at all. The SSD FTLs are just not very good at guessing what the next layer up is doing.
Okay. Sam, could you put it in at the end of this? I
This
need to
this
take a
week I'll
closer look
write
at
up.
get some keywords so I can search it.
Yeah. Or here we put it in chat.
So any questions? Zoom based. Okay.
Just a quick one. Have you received a notification from Avi from SeaStor folks about the summit?
Not yet. I've been checking my inbox every like 2 hours. And
Me too. But
no message
well,
from
it
them.
seems that November is coming, but no agenda, no plans. A bit funny situation.
Yeah. Yeah. We'll see. Okay. Any other questions?
One more thing related to your question, to your concerns about Ceph do for each function. I was thinking about that, and actually, I don't see a good idea to solve it. We could open the SeaStor namespace and specialize those templates there. The benefit is that we don't
Sorry,
need to switch.
Radek?
Yes, sorry.
What is the problem? What is the problem that was identified?
Some background. We are talking about the error handling stuff, error in particular. When it comes to a chain of trust of your error handlers, it's not specific only to error. It's up for error handling in general. It's very likely that you will encounter a function, a callable, that is unaware about your error handler. One of those cases is, for instance, SeaStor do for each method. In order to not impose any extra widely available error rate any widely available to users, to programmers, methods to convert between a error-rated future and a plain future, we need to provide our own handler, our own counterpart for such methods like Ceph do for each. The problem is this is because in case of do for each, SeaStor implementation ensures that it returns SeaStor future of void. So you don't have an easy way, even if you provide a specialization for SeaStor futurize. Those guys like do for each will produce for you a SeaStor future. And moreover, this future is frozen to be SeaStor future void, which makes a lot of pain.
Sorry, I try to understand. Why is there a problem to create our own version of the futurize and then all the likes of do for each?
Yes, we already
because
we just got duplication.
But we are changing the way errors are moved. So yeah, it's reported. So we will need it.
Yes, it's duplication. I would love to avoid such efforts. Actually, we could do with a very small fix, just to return auto instead of future in this particular line of SeaStor. Maybe we could convince Avi for such small patch. I don't know now. We will need to talk during the SeaStor summit. If so, we will be able to.
That's an idea. Yeah.
Anyway, for now we have our custom wrappers. for do for each.
Okay.
Yeah, probably I need to replicate this just for now. Otherwise, we have as the return type is a type error issued by SeaStor.
Yes, current implementation of Ceph do for each doesn't replicate. It's not a copy of SeaStor do for each. It just planifies a rotated future, calls the SeaStor do for each, and turns its result back to a rotated future. It imposes a copy, but it can be also made in a way that there is no copy at all, at the price of duplicating the implementation of SeaStor do for each.
But it's just compile time overhead. It does not lead to runtime overhead. It's a type iteration, right?
Not in C++ 17. You will actually have one move. There will be no copy actually. One move from SeaStar future
Yeah.
void returned from SeaStar do for each that is being called from Ceph do for each, but well, it's a move. All you are doing is basically moving the internal future underscore state in Windows. It's not a big pain, but still, if it will pop up in profiling, we could easily move to a version that doesn't do any move, that doesn't impose any extra moving at all, at the price, of course, of duplicating the implementation of SeaStar do for each, which would be a compile time overhead.
Okay, thank you. I'll try to review your change as ASAP before the end of this week.
Thanks, but well, I think the best we could do with the do for each for now is to move what we already have as Ceph do for each and put it in SeaStar namespace. And that's the first part. Second part will be to ask Avi just to replace those fixed future types to auto. In that way, the return type of SeaStar do for each will be determined by the SeaStar futurized we already specialized in Ceph, in Errorator.
Yes, I think the implementation of a do for each, for example, does not have a lot of leeway so you can return different type of future or of types other than future. I bet this also applies to other helping utility functions in this source file.
Yeah, those utilities usually imposes SeaStar future from void, which means that, well, even if you would go with some outcome, there will be no difference, to be honest. It's a limitation of SeaStar.
Okay.
Kifo, by the way, I made a local performance verification of the Errorator versus master. Basically, looks there is no huge difference, but it's on my local machine with doing random reads instead of sequential reads. In case of sequential,
so you're using the CBT with the change you posted on GitHub, right?
Yes, exactly.
Okay, I'll do it locally to make sure the performance.
Sure. Otherwise, in case of sequential, in case of going with defaults, in case of going with sequential reads, on my machine, the entire run was lasting under half of a second.
I see. Any other questions? Okay. Talk to you later. Thank you, guys. Have a good day.
Thank you.
Good night.
See you.
See you.
Bye.
See you.
Yeah.
Bye bye.